Hello everyone, this is Esfandiar Khaleghi with another CAD CAE Bootcamp sessions. And what we're gonna do, we're gonna go through the assembly side of the Siemens NX, and basically we already developed a model using the 2D and 3D modeling techniques, and now we're gonna put them on top of each other to work as a system, as a product, using the assembly. But today we're going to go through the assembly environment of the Siemens NX, and I'm going to talk about the different type of assembly design approaches using Siemens NX. We're going to use the bottom-up and top-to-bottom techniques to see what's the difference between those, and which one you will use depends on the different kind of situations. Also, we're going to talk about a different kind of assembly constraint and when and how to use those. Also, I'm going to talk about the using the pattern features to make a pattern between different components, constraint that you already made using assembly to make it easier and faster to do. Also, we're going to see how we'll be able to modify the components as well as the manipulating them using the assembly side of the Siemens NX. So whenever we talk about assemblies, basically we're going to make a relation between each individual components of the product that we have. So you can see the majority of products that we have around us is consist of different each individual components, which they have the different reasons for them. Some of them they have different functionality, some of them they have the different shapes and will contribute to the whole system. So by the assembly, we're going to make a relation between them, and what we mean by relations, basically in the softwares, it means the constraint. I think one of the good examples is the Lego bricks. So in order to come up with the shape you're looking for, you're going to use the different Lego bricks to put them on top of each other to make a model. Sometimes you're as simple as the rectangles to just put them on top of each other, but sometimes, for instance, if you want to make a boat or an airplane or a car, let's say, each individual component, they have the different shapes, which you need to put them on top of each other to come to the end model that you're looking for. And in order to do that, you have to see that where to put them on top of each other, basically. So for instance, if there is an extrude cylinder on one side, there is a hole into the other part that you need to put them on top of each other. Sometimes there is an extrude, I don't know, let's say a triangle, and on the other hand there's a triangle cut that you need to use to put them on top of each other, which is exactly the same way that we're gonna operate the Siemens NX or any other software. We're gonna use these areas and use the constraint to be able to put them on top of each other. Assembly is really useful because not only would be able to imagine and visualize to see how your product will look like at the end, you will understand the operation of it as well. You can understand how it's gonna work, so that would be easier for the manufacturing side as well. And also is really useful on the CAE part and the analysis part, because you would be able to put it into the different kind of virtual scenarios that represent the actual reality, and to understand how it operates. For instance, if it's a kinematic, if it's regarding the forces that each individual components would put on top of each other, or what's going on once you put the pressure on one side of the part, but it would impact the other area as well. So the assembly is really important side of the CAD softwares to be able to get these results through it, basically. But once we talk with the assembly, we need to understand what kind of technique we're going to use. Whether we're going to use the bottom-up techniques or top-to-bottom techniques. So bottom-up techniques, basically you start with the first component, which is on the bottom of the system or bottom of the full model, and then continue with the rest of the individual components on top of it. That's using the bottom-up assembly. It's quite well done, and usually we use these methods. However, there's a different version of it as well, which basically is the top-to-bottom techniques, and with the top-to-bottom techniques, you start with the top part as a first part, as a reference part, and then we can continue with the rest. Usually, in order to decide which of these methods you're gonna go for, it depends on what part you would be able to fix it as the first component and then use it as a reference, or also what part would have the bigger size that you can easily fix it and continue. For instance, the model that I just showed to you in here, it's better to go with the bottom-up techniques, because basically these component I can consider it as a first component, fix it, use it as a reference, and the rest will have the relation between based on the first reference. So in here that would be quite easier to use the bottom-up techniques, whereas if I'm gonna go and use the top to bottom technique would be really hard, because basically this one or this one should act as the first component. That will really here make it complicated to continue with the relations between the components. So I'm gonna go and talk about the assembly in details once we go and use the Siemens NX software, because that would be quite easier for you to understand how it works and how you can put it to actual practice. So let's begin the 2-day session on the assembly. So in order to start the assembly, what we need to do, we need to go to the new again, and it can be locked before. There are different ways of opening up and creating a new assembly file, either by clicking here, either by clicking there, or can go into the file and click on new. Also here we can go to the click on the file and new, or we can use Control N. So the same as creating a new model is completely the same as that. You have to make sure that we are into the modeling section, and we need to just, instead of click on the model, we're gonna create a new assembly. And you can see here even these photo represent that you're gonna put things together. So that's the assembly. So something is really important in here. The folder that you're gonna create the assembly file is really important. And what I recommend is better to whatever parts and components you want to use in the assembly to be in the same folder that you're gonna save the assembly file for. So as an example, so you can see, for instance, in here I'm gonna deal with the pipe voice assembly, and you can see I put all of them into the here, and then once I create this one, so for instance I created the base assembly, is also in the same folder. The reason I've done that, because whenever I move these folder, I still have all the links together, because basically what happened, they just have the local links to there. But if I have the assembly file out of this folder, or if each individual component, there are a different folder, this is what I usually see from students. For instance, they have the file, one in the desktop, one into the documents, the other area. Once they move them around, because the linkage will no longer valid, your file won't be open and you get the error, and this is quite common. So it's really important the file you're gonna save is the same location that the rest of your components are. So let me pick up the location that I have the component for. And click OK, and I can name it whatever I want. So let me call it the pipe voice. And click OK. And let the application to load. And you can see the first thing it asks you to put the first component, and usually this window will pop up automatically. So what I need to do, I need to locate the first component. In order to do that, I can click on OK and open here basically, and I can pick up any file that I'm looking for to start with. So here you have to think about what kind of methodology you're gonna start, whether you're gonna go from the bottom up technique, so the first component will do the base, will do the bottom, or it's a top to bottom technique. If that's the case, we will start with the top component that we will want to deal with. So in this case, I'm gonna start using the bottom up technique. So I'm gonna start with the base actually, and you can see once I click on that, I can see visualization of it. If in case this is not active for you, make sure you tick here so you can preview it to make sure it is what you're looking for, and click OK. It might take a few seconds to load, but it's okay. And once it's ticked, sometimes you see visualization of it. If not, make sure you come here and click on the select object, then it will appear. So now I can move around the first component that I imported, and I can pick it up wherever I want. So let's leave it there, and you can see in terms of location I have the few options. The first one is an absolute, and then depends on the next one, the first one will change. So you have an snap, which basically I can put it whenever I want. I can use the absolute work part. So what it does, it will go to the same coordination system of the part. So the same coordination of the the part that I have, if you remember, once we creating these parts, coordination was really important. So whenever you put the coordination of it, it will go and match there. You have another option as well, which is basically is an absolute of it, or also you can go with the WCS, and these two basically put them into the 0, 0, 0. So the absolute is the point of the 0, 0, 0, or what I usually do, to be honest, in here I use the snap and then put them wherever I want, and then put the X, Y, Z, depends on what I'm looking for. If I'm looking for 0, 0, 0, I do like that. If I want to put it on any other locations, you can even modify these. Also, you would be able to use these arrows there to move in the Z axis, to move in the Y axis, to move in the X axis. You will have also the rotations in here. You have the rotation on that directions. You have the rotation of these directions as well. So you have a full control of what you are looking to do in here, and that's the beauty of the location in here as well. Once you import it, you can apply the constraint at the same time, or you can do it on a later stage, which we're going to show both of them together and what's the differences. So let's click on OK in here. And now the software asks me whether you want to fix it. Because it's the first component, the rest of the components, they're going to be assembled on top of that one. So usually the software recommends the first item to be fixed. You can start it by fixing the first item automatically, if in case it's a fully working part that needs even the first component to move. With the rest of components, you can remove that constraint later. So don't worry about it. Let's click on yes right now, and then we can come back and modify it. So onto the left hand side, if you remember, this is the part navigator when we used to deal with the modeling. Same things that you see here. But the first option is the assembly navigator. So whatever components I have here, they will appear in there. And that's the first, that's the assembly level, and that's the components level. Also here you can see the constraints, so you can see the first component was fixed, and if I click on the plus, you can see the base is fixed, and that's why you see the constraint there. And also here is a part navigator. So I'm into the assembly level. If I want to go to the part level anytime, I can come here and double click on it, and now I'm to the part level. If I go to the part navigator, you can see whatever method that I've used to create that part is available there. I can go there, for instance, I can double click on that sketch, change the sketch if I want, come out of it. And if I want to come back to the same kind of assembly level, what I need to do, I need to go to the name of the assembly file that I have, and I can double click, I will go back to the assembly level. What you can also do, you can right click on it and click on the make work part. It's the same as what I was doing. So if you remember, we are into the assembly environment of the software. That's why next to the home tab we have the assemblies tab. This is the main tab, we're gonna deal with it. If you use the creating a new assembly file using the method that I've used, is basically this is how the software will look like. But also there's the other way you can activate and open up the assembly section of the software, is by going to the application. If you remember to the first session we talked about that, and you can see you see the modeling, the sheet metal, shape studio, and so on. Also you would be able to access the assemblies here by clicking to the assemblies. So the same as the first method, basically by creating assembly here, then at the end it will ask you for the name of the file, whereas the first method at the beginning asks you for the name of the file. So let's import another component. If I want to import another component, what I need to do, I need to make sure I'm into the assembly level, and I need to click on the add. Once I click there, the same as the first one, I need to find the location of the component that I have. And let's say I'm gonna use, for instance, let me see which one to use. Yeah, let's use this screw, for instance, and click OK. And so what basically happened, it's put it to the absolute. Let me change that when I put it to the snap, so I can have a full control of it. And you can drop it whenever you want, doesn't matter. And now again, like before, you would be able to rotate it and move them around. But right now you can either move it as what I've done, or you can apply the constraint. If I put the constraint, I can start applying the constraint. The constraint is basically they are the interrelation things that we were talking about. You can do it right now, or what you can do, let me go onto the move and click OK, or you can come back here and apply the assembly constraint by clicking on there. It's absolutely the same things. Rather you do it within 2 steps, you can do it within 1 stage once you import the component, or you can do it into 2 steps. Usually I do with the 2 steps so because I want to have a full control of the assembly constraint. Let's talk about the assembly constraint here. So the first one is a touch align. Basically the touch align is the combination of the few things. The touch is the two surfaces, two faces, they touch each other. The align, the two lines or the two axes, they are aligned. It's the same as what we use in Microsoft Word. Once you put the aligning components together, the same as on any other softwares. Or if there is an axis, you can use the infer center and axis, which basically you can put the axis, you see that? The axis of this one with the same axis of these. And basically both axes would become on top of each other. Or also what you can use, you can go to the preferred touch, which basically automatically software realize which of these you are looking for. You can either pick any of these, or you can let the software decide. If I put, for instance, this one with this one, it automatically realizes that they want to be into the same axis and they are aligned there. Or what you can do, let me do a Control Z here. Or what you can do, if I for instance put the, let's go with the preferred touch, and if I, let's say, I'm gonna just pick up the surface of it, and the inner part, it automatically realize that I'm gonna go with the touch, for instance. So the other one is the concentric. Basically the concentric we use whenever we have a circle or elliptical, for instance, edges, and they want to have the same center points. We use the concentric. So they're quite close to the assembly, to the constraint that we used to use within the 2D and 3D modeling techniques. So the distance, you can put the distance between two different objects, so you always would be able to limit it. You can fix it, the same as what we've done for the first component. You can make them parallel with each other. You can make them perpendicular with each other. You can also align and lock it. So what you would be able to do, you would be able to align them, and so what you do, you align the two axes of the different components, and what happens, it will lock that mechanism as well. So you align it, and also you would be able to lock it. You would be able to fit them. Basically, if you have the cylindrical or kind of, conical faces, which they have almost the same sort of the radius and sizes, you would be able to fit them together, and whenever they work or move, they move together. We have the bond, which basically with the bond, you weld the components together. So they, whenever they move together as a rigid body. You would be able to use the center. So the center, there are the different type of it. Whether you have the one component to you want and actually be in center of the two components, use the 1 to 2. Whether you have the two components that wants to be a central in one component, use the 2 to 1. Or whether there are two components you want to be in the center of the two other components, use 2 to 2. And also we have the angular as well, which basically make an angle between two different components. So all of these things, don't worry about that, and we'll come and talk about it once we go to the depth of the constraints. If you want to find out more about it, so the presentation file that I uploaded, which you have access to, will talk about each of these in details. And also if you want to go there, I put a link for you that if you click on there, will takes you to this page from the Siemens, which basically shows what the Siemens describe about each of these constraints. So let's start from the beginning by doing a pipe-wise assembly. So let me get rid of these, and we're gonna import them and then start assembling them from the beginning, so it would be quite easier for you to start. And this is the first tutorial that actually we are working with. So what we're working here, when it's to decide what methods you want to start. If I remember, we were saying in here we're gonna use the bottom-up techniques, because basically the base, it can be easily fixed and the rest of components can be applied on top of each other easily, and also we can make an interrelation between them. So what I'm gonna do, I'm gonna start with the base, then put this component, then put that component, and then I'm gonna add this component and also put these together. So you can see here is the expected time of 2.5 hours. It is starting from the sketching. We already have the model, so we don't need to spend that much, and you can see it's quite a straightforward and we can easily do that. What I recommend, please watch this section of the video and then pause and do it on your own time. If you would be able to do tutorial 1, you will have a really good understanding of how the assembly works, and then we will take it to the next stages by making it a little bit more complicated. So let's begin. So let me add the first component here. And if you remember, we said we're gonna start with the base because we're gonna use bottom-up technique. So it's the base I'm looking for. I'm gonna click OK. And what I'm gonna do, I'm gonna snap it there and match it with the work part, which is 0008 87.5. And I'm gonna click OK and let the software to fix the first component. So you can see that's the first component that I have. It's called base. Also, if I go to the constraint, you can see the first component is fixed. So the next component I want to import is a screw. So I'm going to import the screw and click OK. And if you remember, so there are different options. I'm gonna use the move first, and what I'm gonna do, I'm gonna go and change this one and use the snap. So basically just gonna leave it somewhere here and click OK, and then I'm gonna work with this component. So whenever we are dealing with the assembly, basically we are dealing with the degree of freedoms, and we want to make the relations to make sure this system works perfectly and properly with the limited number of the degree of freedoms. So we don't want that all the items would have degree of freedoms. So in order to check that, you can come and pick up the item you have, or the part you have, or the component you have. You can right click there, and what you would be able to do, you would be able to click on the show degree of freedom, and you can see here it has all the 6 degree of freedom. You can move up and down, go to the right, to the left, go to the side. It has all the rotations, so all the degree of freedoms it has. Whereas if I'm gonna check this one and I'm gonna check the degree of freedom, it doesn't have any degree of freedom because we already fixed it. So what I'm gonna do, I'm looking for a degree of freedom for this one, which basically would be able to go up and down. So in order to do that, what I need to do, I need to apply constraint. By the way, if you want to get rid of these degree of freedom, well, you can go right click and click on the refresh, or you can press the F5 on your keyboard. So in order to limit the degree of freedom, what I would be able to do, I would be able to go to the assembly constraint and use one of these constraints. The constraint that I'm going to use this time, I'm going to use specifically the infer center axis to put this one to the same axis of this one. But again, if you don't know the type of it, you can go with the preferred touch and let the software to just pick the one you're looking for. This is the 2 I'm looking for, the center line of the base, exactly. So just pick the first area of the constraint you want to have and select the second one, and the software will do it for you, and click OK. So you can see now I put it into the right location, but again it's inside the model, and I need to move the item out. So there are different ways you can move the part. You can either click on here and pick up the component you're looking for to move, which basically is this one, and you can click on the specify orientation, which I would be able to move this one around. Or what you can do, you can either right click in here and also click on the move. It's the same thing, so it doesn't matter which one you're gonna go for, both of them works fine without any problem. And let's check the degree of freedom now, and you can see now the degree of freedom now has been limited to just go up and down and also rotate, and this is exactly what I was looking for. So I don't need any of the degree of freedoms. So let's continue and go to the another component, which is the movable jaw. What I need to do, I need to go and click on the add and look for the another item, which is movable jaw. I'm gonna click OK and let the software to load. So once the item is loaded, I need to click on the select object so I would be able to see a visualization of it. And let's just leave it here using a snap. And what I can do, I can either click on OK and then go and apply the assembly constraint, or I can do it in one go. If you remember, I was saying that you can use and apply the constraint right now. So what I'm gonna do, I'm gonna use the concentric, and I'm gonna pick up that edge with this edge as concentric, which basically have the same centers, and it easily go there and we will fix. And click OK. I can continue applying more constraint, by the way, in here, but I wanted to show you something there. Let's right click and see how many degree of freedom it has. Now it's just limited to go up and down and also rotation. So rather than all the degree of freedom, I just have 2. But what I'm looking for is just these movable jaws should go up and down and shouldn't have any rotation. So what basically I need to do, I need to think what kind of constraint I can apply to it to prevent that rotation. And I have the range of constraint that I would be able to use. What I think in this case would be a really easy thing to do if I use parallel and then say this face is parallel with, I don't know, let's say this one. Then if I click OK, you can see now the degree of freedom has been changed to just go up and down, and this is exactly what I'm looking for. So this is what basically you need to think about. And let's go to the constraint navigator, and you can see all the constraints out there. If I click on the plus, it just says, for instance, the parallel use is between base and movable jaw. But let's apply a wrong constraint to see how the software would show an error for. Let's say I'm gonna use a parallel this time between this one and this one, which is absolutely wrong. And you can see the software shows that error sign, and also in here into the constraint navigator shows that these two constraints that I already applied, they are interfering with each other. So basically I have to remove one of them. And based on how expert you are in the CAD, basically you would be able to understand where you applied wrong. But again, if you are new, it might take a few minutes for you to just use try and error to find out which one is wrong. And this is the kind of question usually whenever I've been approached by the student, they will panic once they get these errors. So don't worry about it, just double check where you see these errors, and you can easily, for instance, inactivate something. For instance, if I untick this one will be inactivated, and I can easily find out which of these kind of constraint would interfere. And I can say, okay, so if that's the case and this one is interfere, what I can do, I can easily right click there and click on delete, and then so everything seems to be fine and I can continue. So this is another way that you can find out how you would be able to solve the problems you will encounter with. So we've done the movable jaw, and this is the same kind of operation I'm looking for. Let's continue with the few more components. Let me click on add, and I gotta look for the handle basically here. Yes, that's okay, and I'm gonna click on OK. Let me snap it here. I'm gonna snap it there. And what I'm gonna do, I'm gonna rotate it as well so that it would be easier for me to work with the part. So it have the same sort of directions. Let me apply the constraint right now as well. As I mentioned, you can easily click on OK and then apply the constraint right there, or you can do it right now. So what I'm gonna do, I'm gonna use the prefer touch, which basically I'm gonna use infer, but let's go and use prefer touch. I'm gonna put this axis with the same axis of this one, which bring it to the same sort of area. But again, if I go to the move, what you would be able to see here, I would be able to move this one around, and this is not what I'm looking for. So basically if I go there and check the degree of freedoms, it would be able to show that it has all the degree of freedoms. So let me click on OK, so it would be easier for you to understand what I'm talking about. If I go there, right click and check the degree of freedom, you can see it goes up and down, also go to the left to the right, but also has these kind of rotation, which is absolutely fine because these items should rotate as well. What I just need to do, I just need to put it into the center because this is not in the center. So I can go to assembly constraint and I can use, let's say, use center, and I'm gonna pick up to the 2 to 1 and select this face and this face. So these two I want to be in the center of, let's say, these axis center line of the screw, and you can see easily they come to the middle, and this is exactly what I'm looking for. Everything is fine, but if in case you want to double check it out, basically analyze your material, you can easily go to the home and click on the measure, and what you can see, I can pick up, for instance, this face, and let's say I'm gonna pick up the center of this one. If I would be able to move this one around, because this one is in the middle of what I'm looking for. So this one, you can see the distance is 86, which is exactly what I'm looking for, and I can double check it with this one. You don't have to, this one it was quite simple, but if in case you have the complex geometry, you would be able to do that. And you can see again it's 86, so it's exactly in the middle, and this is what I was looking for. So let's continue by adding the handle screws. So I'm gonna go to the assemblies again, click on the add, and I'm gonna choose the handle screw, click OK, select the object using a snap. I'm gonna leave it there. I'm gonna use move, so put it in that direction, so it would be easier for me to apply the constraint. I'm gonna apply the constraint in one go, and what I'm gonna do, I'm gonna use the concentric between this edge and that edge, and click OK. Let's put it into the center, symmetric as well, and let's double check the degree of freedom, and you can see this is exactly what I'm looking for, because I'm looking for the rotation but I'm not looking for the translation. So I don't want to move any kind of X, Y and Z, but I'm happy with the rotation, and this is exactly what I'm looking for. So what I need to do, I need to exactly do the same thing on the other part, but I'm gonna teach you something new. That's why I want to go and use a mirror. So you can see here we have something called mirror assembly, and this is the same sort of things we used to do with the mirror in the 3D modeling, but this time we're gonna use it in assembly. So with the mirror assembly, you have to pick up the first component which you want to apply the mirror to. So you can see I need to select the component, which basically for me is this one. I'm gonna click next. I'm gonna pick up this one, and you can see the handle screw come here. I'm gonna click next, and I have to pick up a mirror, something which is gonna act as a mirror, and it should be a plane. So you can see here I don't have any plane I would be able to use. However, I have some kind of references which they are hidden and I would be able to use. So in order to activate them, what I can do, I can come out of it, go to, let's say, this one, right click for instance, and I can click on the replace reference set and click on the entire part, and you can see that's the planes or reference for these handle that I have. If I want to get rid of it, I can go to the replace reference set and click on model, so I will get rid of it. Let's do the same thing for this one. I'm gonna click on the replace reference set, click on the entire part, and you can see easily I have a plane there which I can use it as the a mirror basically. So what I'm gonna do, I'm gonna go to the mirror assembly, click on the select component, click on next, pick up the components I want to use the mirror for. It's this one, click next, and you have an option. I can either pick any of the plane which is existed here, or I can click on there for instance, which basically I would be able to create a new plane. I don't need create a new plane in this case. I'm gonna pick up the plane which already existed, which is this one, and it's going to act as a mirror. Click next, And you can see now the software asks me whether you want to copy the new component or use as it is, which basically you would be able to even add the prefix to it and also add it to the directory that you already have. I'm gonna click on next because I don't want to create a new one. I'm gonna use the one which is already existed, and I'm gonna click on next again and click on the finish basically. So what you can see here, this is the mirror that I have there, and also this is the component that I use the mirror feature for to copy. But there's a difference here. If I click there and change the degree of freedom, you can see I don't have any translation between X, Y, and Z, but again I have rotations. However, if I go and check the degree of freedom for this one, it has all the degree of freedoms, and within the mirror it didn't copy the constraint. So what I need to do, I need to come back and apply the constraints to it again. So in order to do it, what I'm going to do, I'm gonna use move to a little bit move it outside so I can see it better, and I'm gonna use the same constraint that I've used there, which was concentric between that edge and this edge. And now if I click on the degree of freedom, you can see just have the rotations. This is exactly what I'm looking for. If you want to get rid of these, you can easily come there and click on the hide. Let's change the reference of this one. I'm gonna right click on the replace reference set, and this one is part, so I think the plane that I have is from this one. Let's go and change this one to the model, so I get rid of that, and you can see that it's basically almost done. But let's have a look and see how the functionality of it works. So what I'm gonna do, I'm gonna pick up this one and click on the move to see what it does, and you can see it easily goes up and down. If I do the rotation of it, it also rotates without causing any problem with the movable jaw. But there is an issue that if you notice, the movable jaw goes inside the part. I can check it by, even if I click on here, you can see there's an arrow, and if I go to the setting, I would be able in here to go and do an arrangement. You can see here it says collision detection. If I open it up, I can highlight the collision, and let's see what happens. So when I go up, I should be able to see a collision, because what it does is basically goes and interfere there. It goes inside the part. Or if you want to see it better, what you can do, let me cancel this one to bring it back. You can, for instance, go there, right click on it, and go to the edit display, and within the edit display you would be able to change the transparency of that one. So let's change the transparency of this one like that. I think it's good. And now if I move the part, you can see it goes there, and it now it will continue. You can see it will continue up to the time which would have a collision. So there should be a method that I would be able to prevent that. So in order to do it, what I'm gonna do, let me bring back the color of this one, the transparency of this one to the normal. I'm gonna bring it back. Click on OK. So what I'm gonna do, I'm gonna go to the assembly constraint, and I'm gonna go to the distance. With this time I can apply the normal distance. Let's say I'm gonna say this face, the first one, with this one will have a distance of 35. And let's see what happens. I click OK. So what happened here, these two will always has a distance of 35, which basically if I'm gonna move this one up and down, I wouldn't be able to do it. I would be able to rotate them, but I wouldn't be able to move this one up and down. The reason for it, because I fix it as a 35. Whereas what I'm looking for is a range of movement. So what I'm gonna do, let me get rid of this distance, go to the assembly constraint, again pick up the distance, and I'm gonna pick up the same as what I've done, this one, and I'm gonna pick up that one up as well. But rather than I put the distance, I'm gonna go to the distance limit, untick the distance, and now put the upper limit and lower limit. So I'm gonna put the upper limit of 35 a lower limit of 0 and click OK, and let's see what happens. So I found this information through the analysis. I've used the measure to find out what distance I have to have before I have the collisions. So now if I right click and go to the move, what you can see there, it doesn't go up because maximum is 35, but it goes down to the 0 and it goes up by 35, which is exactly what I'm looking for. Of course you can change it to whatever you're looking for, but again this is what I was thinking would be a good option to go for. But of course I could increase this one because this one will go inside and I can continue that by the higher limits, which basically was the time that this one goes to the top of that. So this is almost finished. We've done everything we were looking for. We are having the same sort of movement that we are looking for. Again, if you want to highlight something, for instance in a presentation, you can easily go there and go to the edit display, and let's say I'm gonna change the color of this one, and let's pick up another orange for instance. So you can then talk about, for instance, the movement of the movable giant here. And so that's it basically for this tutorial. So what I recommend, please pause now and then go and redo it at your own time. You might do it with a different number of constraints. There is nothing wrong with that, as long as your full model works properly. There is nothing wrong with it. I could easily use the other set of the constraint in here. You don't have to always follow the same things that I've done. But again, this is the kind of typical things we do. You can see the constraint there. You can, if I go to the assembly navigator, you can see the parts that we use. Here, for instance, we have 2 handle screws because one of them we use the mirror for it, and that's for this one. So let's go with the other tutorial. So in the second tutorial, what we're gonna do, we're gonna make an assembly for a plumber block. And basically, again, it consists of the different components, and we need to decide which of the techniques we need to use for the assembly, whether we're going to use the bottom-up techniques or top to bottom. Again, like the previous tutorial that we've done, it's better to start with the bottom-up techniques because, of course, the base has the bigger geometry. I can easily fix it and then make the interrelation between the different components based on the base that are already fixed. So let's start with the tutorial 2 and see how we're gonna assemble it. So something is really important. You can see I put all of the components that I'm looking for to use in one single folder. It's called the tutorial 2. I put them in one folder, and I'm gonna save the assembly file in here as well. So whenever I move these file around, I wouldn't have any problem with the location of the components. So what I gotta do, I'm gonna click on new. And I'm gonna make sure that I'm into the modeling environment again. I'm gonna click on assembly, and let's rename it to the tutorial 2. Or let's say we put it as a promo block. It doesn't matter, so at least we can recognize which one it is. So now what I need to do, I need to make sure I save it into the same folder that I created. For this one, I need to go up and put it into the tutorial 2, which you'll see the rest of the parts there, and I'm gonna click on OK. So I need to pick up the first components I want to start. If you remember, we were saying that we're gonna use the bottom-up technique, so I have to start with the base basically here, which is the casting. So let me click on open. I'm gonna pick up the casting as the first component. I'm gonna click OK. Let me snap it here, and I'm gonna put the reference rather than absolute in here. Let me use the let's see which one is better for me to use. Absolute work path doesn't matter, to be honest, that much, but again, let me go and put it as a 0, 0, 0. So once I'm gonna continue, I can have a better understanding of what I'm doing. I think that was really good. I assume that 0, 0, 0 put it exactly in the middle. It put the reference exactly in the middle, which is really good. And I'm gonna click on OK. The software asks whether I want to fix it or not. Yes, please. I'm gonna start with the fix, and of course, whenever I want, I can easily go back to here and unpick the fix as the constraint. So now I need to bring another component because I'm going to use the bottom technique. Basically, I'm going to bring another component that is going to be assembled on top of this one. So what I need to do, I need to go from the Home tab to the Assemblies tab. Click on Add or Add Component. And the second component is the brasses here. I'm going to click on OK. I'm going to use the snap method again. Let's leave it there and let me actually rotate it so I can have a once you rotate it, it will be quite easier for you to apply a proper constraint. You can apply the constraint right now as well, or can use it later. What I'm gonna do, I'm gonna use you can use the concentric on infer in this case. Let me use the infer. You can use even prefer touch or infer, doesn't matter. What I'm gonna do, I'm gonna use an infer between this one and infer of this one, so you can bring it back to there, and you can see it goes inside, but it's not exactly in the middle. So I need to use another sort of infer as well. What I'm gonna do, I'm gonna use this axis and put it to the center of the axis for this one. You can have a look in here. So what it does, it brings it up. So what I've done basically in here, I use the two infer. One was for, let me change the transparency of this one, so hopefully it would be easier for you to understand. The first infer that I used was basically because of this one. So I used the infer of the base with the brass in here. And then I used another infer again with the brass and also the base as well. So I used the two infer in this case. Let me bring back the transparency of it. And click OK. And let me continue. So in order to make sure I've done the correct constraint, what I'm going to do, I'm going to click and check the degree of freedom. And you can see it doesn't have any degree of freedom and it's been fixed. And that's exactly what I was looking for. So what I'm going to do, I need to continue and bring one more component there. Let me zoom in. I'm going to click on Add. If you see one part is already selected, make sure we unselect that. I assume was the brass. I don't need it. So let me click there. So it's really important once you're going to click Add, you didn't highlight any kind of components before, because otherwise it assumes that they're going to use it one more time. And so you can see here right now into the select part is 0. So what I'm going to do, I'm going to bring the cap and click OK. And I'm going to use the snap again. Let's leave it there. Let's rotate it as well. I'm going to go to move. Let me rotate this one. Seems to be okay. And click OK because I'm going to apply the constraint later. So let's have a look for the degree of freedom. And you can see I should get all the degree of freedoms. Whereas what I'm going to do, I don't want any degree of freedom. So what I can do, I can use infer again, which basically between these two holes, I can use two infer, or I can use two concentric. Even if you want, you can use a two touch, doesn't matter, both of them are correct. So let me go to the assembly constraint. I'm going to use concentric, and what I'm going to do, I'm going to put this one with that edge as concentric and click OK. What you will see here, it's their assembly and you think it's right, but let's double check degree of freedom. And what you see is steady rotates. So what does it mean? It means that if I go to the move, I would be able to get that rotation, which is not what I'm looking for. So again, what I can do, I can use infer between those two. I can use touch between these two, or I can use one more concentric. Let's go and use one more concentric between this one and what I have there. And click OK. Let me bring it back to the symmetric. And now if I check degree of freedom, let me check degree of freedom. I shouldn't have any degree of freedom. Let me refresh it. So it's really important to refresh it because otherwise it wouldn't show the updated one. And you can see I don't have any degree of freedom here. And this is exactly what I'm looking for. So I've done the cap. Let's bring more components. And you can see I'm using the bottom-up techniques. First component, second component, and a third component.
So let me make sure I don't highlight any component. I'm going to click on add. What I'm going to do, I'm going to go to the open, and now I'm going to look for bolt. Click OK, use the snap again. Let's leave it there. What I'm going to do, I'm going to rotate it because I need to use it in that directions. It's okay, and I'm going to leave it. Now I want to apply the constraint. For constraint, what I'm going to do, I'm going to put this one into here, and I want to prevent movement. So what I can do, I can use the infer to put it exactly in the middle of here. And then I can use touch on the back to make sure this one will touch there. And then I need to prevent the rotation of it, which I can use the parallel. But again, rather than having a 3 constraint, I'm going to use 2. So what I'm going to do, I'm going to use a concentric instead. And a concentric between this one and the edge of these, which is here. And you can see it's easily go there and will fix. But let's check the degree of freedom, because still you will see I will get a rotations, and this is not what I'm looking for. So in order to stop the rotation, what I can do, I can go to the assembly constraint again, and let's go and use, for instance, parallel. And what I'm gonna do, I'm gonna say that face wants to be parallel with this one, and I'm gonna click OK. And if I zoom out and check the degree of freedom, I shouldn't get any degree of freedom, and this is exactly what you will see here. So I've done that part as well, and let's go and to put the knot. I'm gonna click on add. Let's bring the knots here. It's not. Click OK. I'm gonna use a snap again. Let's snap it there. It doesn't matter. And I'm gonna use concentric again, and it's a concentric between this one and the edge of it. If I would be able to get hold of right, put this one, so the inner part of it. Click OK. Let me zoom in, put it to the isometric, and let's see what kind of degree of freedom you will get. And you can see it's just rotation. It is exactly what I was looking for. So I don't have any other translation or movement. For instance, what I'm gonna do, I'm gonna bring the lock nut here. Let me unselect the component, click on add. Now I'm gonna go and pick up the lock nut. It would be the exact same method that I've done here. I'm gonna use a concentric. As I mentioned, if you prefer, you can use touch or infer. It doesn't matter which one you're gonna go and use. I'm gonna pick up that edge, and let's pick up the inner part of it. Click OK. Let me zoom in, put it to the isometric, and let's just check the degree of freedom. And you can see it's just a rotation. This is exactly what I'm looking for. So I have to repeat these one more time and to put it onto the other area. But what I'm going to do in order to import the components, I'm going to use the mirror, the same as what we've done into the previous tutorial. But for mirroring, again, you have to have a reference plane in between, or a mirror technically. And in order to do that, I'm going to find a plane that I'm going to use. Let's check, for instance, I don't know, let's check this one and see whether I have any kind of, plane in the middle. Let me see whether the designer had anything there. Not this one. Let's go back. How about these? So it depends whether the designer used the, yes, this one was really good. So the designer, whether use the symmetrical design or not. So you can see I have a plane in between, and I can easily use it as a mirror. So what I'm going to do, I'm going to go and click on the mirror assembly. Select the components I wanted to use, basically. Click on next. The components I want is this one, knot, lock knot, as well as the bolt. I'm going to click on next. I need to pick up the plane I'm going to use as a mirror, and that's why I found the mirror. The plane, the reference plane is this one, and click on next. And again, I'm gonna use everything as default, and I'm gonna click on next, next, and finish. If you want to get rid of that plane in the middle, you can easily come there, click on the hide. Let me also change the this one, the reference set to the model as well. And you can see it's almost finished. But if you remember from the previous tutorial, all of these, we didn't copy the basically the constraint. And if I get the degree of freedom from them, they have all the degree of freedom. So what I need to do, I need to come and do the things that I've done. If you remember, we've then used concentric parallel for this one, and we use the same thing for the bolt. You can do it at your own time, or if you want, let me quickly do these things again. So what I'm gonna do, let me get rid of this one and move it, so that would be easier for me to quickly apply the rest. I'm gonna bring it out. Okay, so what I'm gonna do, I'm gonna go to the assembly constraint. If you remember, we said we're gonna use the concentric between this one and there, and I'm gonna use a parallel between, let's say, doesn't matter which one we're gonna go for. Let me choose this one and the other one. So that's it for these. And let me get rid of this one. Let me bring it out. I'm gonna bring this one out as well. So this is just a repeat of what we were doing to make sure that everything is fully working about the same as what we're looking for. I'm gonna apply the assembly constraint like before. I'm gonna use the concentric between this one and the inner edge of it, and I'm gonna continue with this one again as a concentric and the inner edge of this one, and that's it. So if I check the degree of freedom from this one, it should be just a rotation. You can see just the rotations. And also if I check the degree of freedom for this one, I wouldn't have any degree of freedom, and this is exactly what I'm looking for. So that's it. We quickly done this model, and you can see you will get a speed once you do the first tutorial. With the second one, it will be really easy and straightforward for you. So that's for the second one. Let's go and do one more using the pattern features. So let's do the third tutorial on the flange coupling. Make sure again, like before, we're gonna go there and make sure all the components is in the same folder that I'm looking for. It's just three. It's a bolt, flange, and a knot in this case. And what I'm gonna do, I'm gonna create a new assembly file. Make sure it's saved to the same location that I'm looking for, flange coupling. Let me put the name of it in here as well. So I can of course rename it later. It doesn't matter. I just went ahead with this name, but of course I can come back and rename it. As long as they're in the same folder, it doesn't matter. So what I'm gonna do, I'm gonna click on open and bring the first component. I'm gonna start by bringing a flange because I'm gonna use it as the main base, and click on OK. And let's snap it somewhere in here. And let's go to the move and put the location of the 0, 0, 0. I'm gonna use the absolute, but I'm gonna have a look first. I think that would be good, to be honest. Okay, let's click on OK, and I'm gonna fix it as well. Doesn't matter for me because I can easily get rid of it later. And I'm gonna bring it one more time. So I'm gonna go to the assemblies, click on add, and I'm going to bring the flange one more time. Let's use the snap, put it there. I'm gonna rotate it so then it will face the first flange. Now, in order to use a constraint, you can see if I go to the degree of freedom here, I have all the degree of freedom, but this is not what I'm looking for. So in order to limit these kind of movements, is basically I have to decide what constraint to use. There are various of that. Let's go with one, and then I'm gonna pick up the another one and will tell you what's the reason. I can start by infer. Let's go and say I'm gonna use, for instance, in here, and I'm gonna pick up the infer between this one and infer on that one. Then I have to use touch to make sure they meet each other. But there's a problem here. If you notice, if I'm gonna right click there and move this one, have a look closely to the holes. you can see they will rotate and block each other. So I have to use another infer between these two holes to stop the movement. So at the end, what it will happen, basically I will come up with the tree, because let me do it to just tell you what I mean exactly. So it's basically infer between, let's say, this one and that one. Click OK. So now if I check the degree of freedom, this one wouldn't have any degree of freedom. But again, you can have a look. I applied the three basically constraint. Whereas I could easily do it with two constraints. If I apply the concentric and infer, I didn't need that one. There is nothing wrong with that. But again, it's in terms of saving time, in terms of the complexity of your model, all these things might change. So let me do Control Z to get rid of these. So now I'm going to use the different type of constraint. What I'm going to do, I'm going to use concentric this time. Let's say this one. With the other one, they're concentric. You basically have the same center. Now I just need to apply one kind of the infer, so to prevent basically the movement of the flange. That's it. Click OK. Let's put it to the isometric. And now I think it didn't pick up the infer because it doesn't show it here. So now if I check the degree of freedom here, let's have a look. I should have the rotation because I didn't pick up the last one. You can see it has the rotation. So in order to do it, what I was trying to do, which the solver didn't pick it up, was using the infer. I'm going to use the infer between this one. I'm going to do the same things on there as well. Hopefully I can pick up the center line. It's okay. And now if I check the degree of freedom here, you can see I don't have any degree of freedom. And this is exactly what I'm looking for. So rather than I use three different constraints, I just use two. So that will be easier to continue. Let's go and bring the nuts. So let me make sure I deselect the component that I have. Click on Add. Let's bring the, instead of nuts, let me bring the bolt first. And I'm going to leave it there. And now I'm going to apply the constraint right now. Again, in here, what I can do, I can use the infer and touch, which basically I'm going to use the infer between this one and this one. But again, I have to use the touch between this face and the back of the bolt to be able to touch it. But again, I can easily use concentric. Let's do the concentric, for instance, between this one and the back of the bolt. And then I will just do things with one constraint rather than having this various constraint. And if I get the degree of freedom, I should only get the rotation. And this is exactly how the bolts blocks, because you will screw it and unscrew it. Done. With one constraint, I could easily do it. And in this case was the concentric. Again, let me bring back the knot in here. Let me click there, look for the knot. And let's snap it there, for instance. I'm going to apply the concentric constraint right now. Again, you could use the infer and touch, but again, concentric in this case is one go. So what I need to do, let me see whether I can get, because this one has the thread inside. Sometimes once you're going to use the concentric, you won't be able to get, do you see that? It doesn't give you the option to get the edge of it, whereas you can get it from the other side. So what I'm going to do, I'm going to flip this one around. So that would be easier for me to then put it to the same way that I'm looking for. So I'm going to just flip this one around, then go to the constraint, use concentric in this one, here as well, and then in one go, done. Check the degree of freedom, rotation. Exactly, this is what I'm looking for. So now I need to continue doing that 5 more times, but it would be an easier option to do. If you remember, this is what we've done for 2D, this is what we've done for the 3D as well. We use the pattern features, or even pattern curve. Now we have the same sort of things. In the assembly, we call it the pattern components. So I'm going to click on pattern components, pick up the components I'm looking to use. So for instance, I think automatically pick up the back nut. I'm going to pick up the bolt as well. And what I'm going to do, I'm going to pick up the circular as a radius, as the layout. I need to specify a vector. Let's pick up this one, which is the y-axis. And I need to specify a point. Hopefully, if I can find a point in the center, which I have, that would be fantastic. Yes, great. So how many do I want? I want 6. And I want they have the same distance with each other. So it's a 360 degree. It would be 60 degrees between them. So it would be a pitch angle of 60. And now I can click on OK. And the beauty of using the pattern, it also copy the constraint as well. So let's have a look in here and see the degree of freedom. It should be only the rotation. This is exactly as the first one that we use. And that's the difference between using the mirrors and the pattern. With the pattern, you will copy the constraint, whereas with the mirror, right now it has a limitation, doesn't let you to basically copy the constraint. So that's it. Basically, the assembly has been done. Let me show you something else as well. It's called the exploded views. Within the exploded view is a really good representation for you to understand how you've assembled it. It's one of those things we usually use it for the presentation or once you're gonna show it to the rest of the team or your line manager. If you go to the exploded view, you can see right now you don't have any explosions. That's why everything is switched off. If you click on the new explosion, you can rename it. Let me put it as the exploded view, for instance. So again, in here, if I go to the exploded view, you can see I have the explosions, the exploded view and no explosions. And let's go with the one that I just created called exploded view. And let's use the auto exploded component and edit explosion. So the auto exploded, the difference is just, you just pick up the one you want to move. Let's say this one, all of these 6 bolts and click OK. And then you just need to put the number, a value for the distance. In this case, let's say I'm gonna put, for instance, let's put it as 120, but in the minus because it's the positive y, so I'm gonna put in the negative y. So with the minus 120, and you can see they move around. Let's move the flange, but this time I then use the automatic. I'm gonna use the edit explosion to tell you what's the difference. So I'm gonna go to the move objects. And you can see I can manually move this one around. So let me select it first. I didn't select this one first. Select it first. Click on the move object. And you can see I can manually move this around and let's say put it to the minus 15. So that's the difference between just using the automatic or the manual one. Doesn't matter. So this one is also fine. What I'm going to do, I'm going to move this one 15 again. And also I'm gonna use auto explosions between the 6 knots that I have there and put it this time as 120. And this time is 120 positive. And let me move this one manually. So I'm gonna go to the edit explosion, select this object, move the object by 15. Okay. And click OK. So that's it. And you can see, let me put it to the isometric view. It's a really good explosions for this one because this one is quite simple. And you can see I can change the view from the explosions to the no explosions. I can even have the new one, depends on the new model, what you will have. It's a really useful tool, to be honest, for the presentations and also talking about your design, how actually assemble them. So that's for this one. And hopefully you learned something new about the assembly. And what we're going to do, we're going to continue and going to the 2D drafting, or let's say technical drawing. And that's for this one, and see you in another video on the technical drawing. Thank you and take care.